Hey, 20s. All right, so I'm going to give you a little intro on matters and solutions, acids and bases. Just going to give you a start here. Stuff's pretty straightforward. You may have been introduced to some of it before, but make sure with this unit, the stuff seems very easy. But what you need to understand is you still need to do the practice and go through stuff because what I've seen countless times is people underestimate this unit and then they don't do it very well because they make a lot of silly mistakes that could have been fixed just by doing the homework and practicing things. Okay, so first thing, a solution. Okay, so a solution is a homogeneous mixture with a combination of a solute and a solvent. Okay, so we all kind of know what a solution is, or you can kind of imagine it, but important parts to understand is a solute is a substance that is being dissolved. So, for example, the powder. Okay, so here's my little demo over here. You've got salt or sugar, some kind of solid. Um, this is going to be the solute. So, what I always think about is something like a powdered drink and the solute is the powdered part. The solvent is whatever you're mixing it into. So the universal solvent is water, and often we talk about a solvent as water. Together, when you mix the solute and the solvent together, you make a solution. Here's some different types of solutions. If you care to read through these, or you should read through these, have a look. I'm not going to go through all of them, but they're pretty straightforward. So, for example, gas and liquid pop. You just pay attention to what the solute is here, and then what the solvents are, and then some examples in real life. If you look at things like alloys and amalgams, some cool things to look up. You can look on the online about them. They're pretty neat, actually. Okay, so when you are dissolving something, you need to understand that there's energy being released and absorbed in this process. So endothermic reactions is energy going in, exothermic reactions is energy going out. So essentially, the force that holds the particles together, the solutes, there's energy going in that breaks that apart. That's endothermic. There's also going to be endothermic reactions or endothermic energy going into the water being separated in that process. So we got energy in, and then as all of a sudden those solute and solvents mix together, well, there's an exothermic release of energy during that process. So exothermic, just so you can remember, energy in, as you can remember by Hugh Jackman down there. So electrolytes, they conduct electricity in a solution. Non-electrolytes will not conduct electricity in solution. So shocking, I know. Okay, so what that means is electrolytes. You've probably heard that term before. Gatorade. Okay, Gatorade is something that we use in um, because we use that in things like working out and stuff like that because they allow electricity to be conducted in our bodies. And then when that happens, we can um, get our neurons to work and get our signals to be transferred. Non-electrolytes, they don't conduct electricity. So these ones conduct electricity. These ones do not. Okay, so dissolving is kind of a term that's been used openly, but the big thing with this one is there's three different terms you need to understand. The first one is dissolving. So when a non-electrolyte dissolves in water, the particles of solute separate from each other. Um, Another important part here: polar molecules tend to dissolve in water, and non-polar molecules do not. So this is the whole um, like dissolves with like. That's from when we're doing bonding, understanding that polar molecules mix with polar, non-polar don't mix with non-polar. For an example here, sugar cubes dropped in water. Okay, so sugar is a solid. This arrow indicates water, and sugar is now in an aqueous form. So what that looks like, sugar dropped in water. If you have a molecular compound, sugar compound is C6H12. H12O6, and it's going to be a solid. So this is solid sugar. All of a sudden you mix it into water, well, it's going to stay as C6H12O6, but now it's going to be in an aqueous form. You've all experienced this. If you ever mix a sugar into a drink, it still tastes like sugar after. So that's the big thing here. If you have a solid form, if you taste solid sugar, it tastes the same when it's in aqueous form in solution. And I'll come show you why that's different than our next one. So that's dissolving. So dissolving is when a substance stays in the same chemical structure as a solid and then as in the aqueous form. Okay, so this is the next one. This is dissociation. So dissociation is with, first of all, it's going to be with ionic compounds. Okay. So ionic compounds, you need to be able to identify the difference between ionic and molecular. You're probably better at this now after going through bonding. But here we see this is an ionic compound. We have sodium chloride, a metal, and a non-metal. When this gets mixed into water, it produces sodium ions and chloride ions. Okay, so notice how you got this part here. You got the ion and the ion. Okay, so notice how this is not Cl2. Okay, that's different. That's a gas. This is an ion. This is a molecular compound. Very different things. So just because you see this here, do not make Cl2 out of it. So sodium chloride, it breaks down with water into its ions. These you can just look on your periodic table. Um, the number in front is very important. Okay. So sodium chloride, we have one sodium and one chloride ion. That's what is happening with dissociation. This one here is going to be, I'm just going to add the state here. This would be a solid. Okay. Calcium chloride. Notice how calcium has, there's one calcium, there's two chlorine. When you put them into water again, okay, that's that arrow. Notice how we have one calcium ion and now we have two chloride ions. Okay. The states of these ions is aqueous and aqueous. Okay, so notice that state change that happens when they go into water. They split apart, they break apart into ions. Okay, insoluble or solid in water. Okay, so here is understanding the solubility table. These two things are soluble. This guy here, if you look on your solubility table, is insoluble. Actually, that's not true. So I'm gonna erase this. It is if we're being true, it is slightly soluble. So what that means is, I'll show you what that means in a second. But notice here, if you look on your table and on your solubility table and you see magnesium hydroxide, well, it's going to be a solid. And all of a sudden, when you mix this one with water, notice how now this is not aqueous. This is a solid. Okay, so that's what the slightly soluble means. It's staying as a whole compound. Up above here, we have something that's going to be soluble, and it is becoming its ions here. This one, insoluble or slightly soluble, solid in both situations. Shocking, I know, still. Okay, third one then. So all these different terms are all how we would talk about dissolving. But with now our new understanding of solutions, now we have something that's not all of them are dissolving. You have dissolving, which is molecular compounds. You have dissociation, which is for ionic compounds, and now you have one more here, ionization. So ionization is for acids. Okay, so some acids compounds form ions. Okay, and these are six strong acids, and these form ions. So here's your six strong acids. right here listed for you, and you need to memorize and know which ones these are. So here's the chemical formula for each one, and you just need to be able to identify which one is which. Okay. So what happens here, for example, if you have HCl, it's going to be a gas. When all of a sudden you mix it into water, well, it makes hydrogen ions and chloride ions. And that is what's happening is the ionization. When it's an acid, it's not dissolving, it's not dissociating, it's ionizing. Okay, so ionization is a term referred to um, reserved for acids. Okay, so we have more than these six acids in general. These are strong acids. Down below here, this is a weak acid. Okay, this is phosphoric acid. So if we're looking at phosphoric acid, here's the compound. When all of a sudden it gets mixed into water, it becomes, whoops, it becomes the exact same thing. It does not create ions when it's a weak acid. Okay, weak acids, they stay together. So notice how this one splits apart into those ions. This stays together as a compound. Okay, this is weak down here, and this is a strong acid. So make sure you can understand the difference and you can identify your acids, strong acids and weak acids. Okay, so just to recap, we got dissolving. So an example, methanol. It's going to be in a liquid state at room temperature. When you mix it into water, well, it becomes this. So it stays together because it's a molecular compound. Okay, remember that for bonding, molecular compound. Dissociation, we can get two different situations. One would be something in our on our solubility table that will dissociate. The other one would not. So an example would be sodium nitrate, and it's going to be a solid. When we mix it into water, it becomes sodium ions and nitrate ions. Okay, notice how there's one of each. There's one of each over here. If you also have something that's not soluble, for example, calcium carbonate. So this is what we used in our lab. We actually had calcium carbonate. When you mixed it into water, it is only slightly soluble, so it stays like this. And this is why when you do calcium carbonate in water, it was all cloudy and not clear. If you mix something like this in, you won't be able to see the ions present there. Last one is ionization. And that is reserved for acids. So an example would be nitric acid. When you mix nitric acid into water, it becomes H plus and nitrate ions. Okay, so there's your different things for different parts you have. So solubility. I am going to leave this for you to read over. If you have any questions, we can go over it on Wednesday. But yeah, make sure you read through these and understand these. Saturated solution means that they're just everything. There's a certain amount of ions that water can hold, and that is what happens here with saturated solution. Unsaturated means that there's more Ions are things that can be dissolved in it. Supersaturated means there's more dissolved in it than there should be. Other things here. Gas solubility. Think of a can of Coke, okay, when you read about this, or any pop. Um, and yeah, make sure you understand these different temperatures of solubility and how pressure affects the solubility. Okay. So if you have any questions, we'll cover them on Wednesday, or sorry, next class. And yeah,